Here we're going to talk about how you can figure out how many solutions a system of equations has just by looking at the equations. Remember, with a graph of a system of equations, the solutions are any points that they share in common. So if there's an infinite number of solutions, that must mean that they are the exact same line. They share all the points in common. That if we graph one line and then graph the second line, we'll see the second line lays right on top of it. So they share every single point in common. That's why there's an infinite number of solutions. So the way you figure this out, if you're given some equations like these all have an infinite number of solutions. If we look at each set of equations, they don't look exactly the same. But is there something we can do to modify one of the equations and see that they're the same thing? Like, first step, you want to line the x's and the y's and the numbers on top of each other. That first one is in that format. And if I look at the x's, this one's 2x and this one's x. But think, what can I multiply that first equation by so it's also 2x? If you multiply that entire first equation by 2, so if we multiply x by 2, we get 2x. Multiply y by 2, we get plus 2y equals 10. Notice it is the same as the second equation. That's why there's an infinite number of solutions to this system of equations. Let's look at the second one. Can we multiply one of those equations by a number and then they're the same? If you look at the y's, notice we have y and 2y. So if I multiply that whole first equation by 2 again, just like in the first set, we're going to have 2y equals 8x minus 10. It's exactly the same as the second equation. They're the same things. If I were to graph the first equation as it is on a graphing calculator, I would see it's the same thing. The third one, we have to first put them in the same format. Notice the equal sign is in a different place. So let's move that 3x over to the right side. So how can I move that 3x to the right side? I can subtract 3x because 3x minus 3x cancels. So I'm going to have y minus 3x equals 2. All right, now let's look at this one and this one. They're not exactly the same as they are, but look at that second equation. If I multiply that whole thing by 3 so that the y becomes 3y, then this would be 3y minus 9x equals 6. Same thing now. So if you notice that the two equations are the same, perhaps you have to multiply one of the equations by some number, but then they're the same thing, there's an infinite number of solutions to that system. So if you're looking at some equations, you notice, nope, they're not the same, but you notice that they are parallel lines, then that means there's no solution at all. So if they're parallel lines, they're not going to intersect at all. When you graph one of them, it's here. You graph the other one, it's here. These lines go on and on forever. They're never going to touch. So to see if something is parallel lines, then everything is the same except for the number. So the number in front of the 2x, the number being multiplied by 2 is the same, the number being multiplied by y is the same, but they're both equal, like in the first set of systems of equations. Notice they both have 2x minus 6y, but this one's equal to 13 and this one's equal to 5, but these are the same. So that means these are parallel. The same with the second set system of equations. We have 3x plus 2y, but this one's equal to 8, this one's equal to 3. If we graph these two equations, we would see that they're parallel. The third one, you can't tell yet, but just like with the infinite number of solutions one, think, is there something I can multiply that first equation by so that 2y is 4y? How about 2? Let's multiply everything by 2. So we get 4y minus 12x equals 8. So they both have 4y minus 12x, but one equals 8 and one equals 10. So they're not the same exact equation. If you graph it, they are parallel. So no solution. So if there's not an infinite number of solutions, and there's not no solution, they're not parallel like this, then there must just be one solution. So if they're not the same exact line and they're not parallel lines, they must intersect in one point. So that's the third option. If you graph one equation and you graph the other equation, they're not parallel, so they're going to intersect at some point. That point is the solution. So again, what you're doing really is just looking to make sure they're not the same line, where there's infinite number of solutions, and they're not parallel, where there's no solution. So if we look at the first one here, is there something we can multiply that second equation by so it equals the same as the first equation? Something we can multiply, because the y is the same. This is 2x, this is negative 2x. If I multiply that first equation by negative 1, I'm going to have negative y equals negative 2x minus 3. There's nothing I can multiply one of the equations by and have them be exactly the same. Also, with parallel lines, the y's and the x's need to be the same. It's the number that can be different. So this means one solution. The second one, the x's and the y's aren't lined up yet. So I'm going to do like I did on that previous page, and we're going to move the x over to the left side. So let's do that by subtracting 3x, because 3x minus 3x is 0. So we have y minus 3x equals 1. Or this we have x and then y. So let's change that to negative 3x, and that's a positive y, equals 1. So if we compare that to the second equation, 5x minus 3y equals 2, they're definitely not the same equation. The x's and the y's aren't the same. Is there anything I can multiply one equation by to make it equal the second one? No. So this one would be one solution. And the same for the last one here. Let's put them in the same format. So let's move the x for that second one. So we have the 2x plus 5y equals 4. Let's move the x over to the left side. So we have y minus x equals negative 6. And let's change it so the x is first, that minus x is first, and that positive y is second before we compare it to that first equation. And now let's take a closer look. Is there something that we can multiply that second equation by so that the x and the y are the same? If we multiply that second equation all by negative 2, then this would be 2x, which is good. But the y would be negative 2y, and this would be negative 12. So the x's match up, but not the y's, so it's not parallel, and definitely the whole equation isn't the same. So this would be one solution. So again, for infinite number solutions, everything should be the same. You might need to multiply one equation by some number and to realize that they're both the same exact equation. With parallel lines, the x's and the y is the same, and they just equal some different number. These are parallel lines that will never intersect. Again, you might be in a format like the first two where everything is the same. They're just equal to some number. It's very obvious. Or you might need to multiply one of the equations by something to realize that this equation equals this equation. And then the one solution, again, you're just eliminating, making sure that they are not infinite solutions. They're not the same exact line, that they're not no solution, they're not parallel lines. If they're not either of those cases, assume that there's just one solution. So you're just putting them in the same format, the x's and the y's, and seeing if the x's and the y's happen to be the same, if you can make them be the same. And if not, then there's just one solution.